Arif. So today I'm going to talk about superposition theorem. So what is superposition theorem? Superposition theorem is one of those strokes of genius that take a complex subject and simplify it in a way to make perfect sense. The theorem like Miller's certainly work well, but it's not quite obvious why it works so well. Superposition, on the other hand, is obvious.
Hello, now I'm going to explain about how to calculate each value of current and voltage inside each resistor. Now we are going to connect the resistor as the diagram given here. The 10 voltage supply comes here and also the 5 voltage supply comes here. And this is the 10 kilo ohm resistor. This is the 20 kilo ohm resistor. And this is the 30 kilo ohm resistor. Now, first we're going to short circuit the 5 volt and calculate the 10 voltage of the resistor first.
Look at the V20 k ohm and we short circuit the 5 volt. We got the only 10 volt. So for the volt for 10k ohm resistor, the value is we got 8.3 volt. So after that, for the volt for 20k ohm, we got 1.853. So lastly, for the volt for resistor 30k ohm, we got the same 1.853 volt. As we know, after we short circuit the 5 volt, we need to short circuit the 10 volt. So the circuit when we short circuit the 10 volt like this. So as I use the same polarity as before this, we're gonna get the volt for 10k ohm resistor. So the value is negative 1.382. After that, we're gonna measure for volt for 20k ohms. We get negative 3.692. And lastly, for volt for 30k ohm, 1.382 volt. As we get for the voltage source after we short circuit the 10 volt and 5 volt, we sum up the value. So 8.3 to minus 1.382, we get 6.918 volt. So for voltage for resistor 20k ohm, 1.853 volt minus with 3.692, we get negative 1.839 volt. So lastly, for the V3 or V30k ohm, we get 1.853 minus by 1.3 and plus or sum with 1.382, we get 3.235. So this is we calculate one by one. So now let's take a look for voltage source when we connect all of this voltage. Firstly, for 10k ohm, so the value is 6.92 volt. So straight away we get the same value of the calculated and experiment. After that, we're gonna see for voltage for the 20k ohm resistor. So the value is negative 1.840 voltage. As you can see, the value is quite the same, only 0.001 approximately change. So lastly, for voltage for resistor 30k ohm, we got 3.235. So the value is the same, no change, it's 100% same. So we can conclude that the superposition theorem is verified.
The superposition theorem, I'm going to explain about the limitation and application of superposition theorem in daily life. First of all, for every electrical circuit, there are two and additional independent supplies like current and voltage are both other sources. For determining this electrical circuit, superposition theorem is the widely utilized and most time dominant circuit as variable frequency. For instance, linear DC circuits consist of one or more independent supplies. We can get the supplies like voltage and current by using methods like mesh analysis and nodal technique. As well as teaching us like that, we can use the mesh and nodal analysis with the aid of superposition to find the real value of the voltage and current. Otherwise, we can employ the superposition theorem that includes every individual supplies, result on the work of this variable to be decided. This means the theorem assumes that every supply in a circuit independently describes the rate of the variable, the lastly produce the secondary variable by interesting the variables which are reasoned by the effect of every source. Even though the process of this is very difficult, but still can apply for linear circuit. Now, the superposition theorem can be useful for the power calculations. So I said before this, but this theorem works on the principle of linearity. As a power equation is not linear. As a result, the power used by the factor in the circuit this theorem is not achievable. If the load selection is changeable, then it is necessary to achieve each supply donation and this calculation for each transformation in load resistance. So this is a very difficult method to analyze compound circuits. The application of superposition theorem is we can employ only for linear circuits as well as the circuit which has more supplies. From above superposition theorem example, this theorem can be used for non-linear circuits but applicable for linear circuits. The circuits can be examined with single power source at the time. The equivalent section current and voltage algebraic include discovering what they will perform with every power supplies in effect. To cancel out all except one power supply for study, substitute any power source with a cable, restore and current supply with the break, which they are explaining about. We can find out the voltage or current supply by short or open circuit up each of the independent source.